So we are going to continue on with this whole idea of using SOHCAHTOA and right angle trigonometry to now solve some visual and worded problems, and that brings us on to angles of elevation and depression. Angles of elevation and depression are just terminology that we use in trigonometry to describe angles going up and angles going down. Okay, so for an angle of elevation, all we do is we start here at the horizontal and elevate. You would think that you would be going up, so it means the angle measured going up to the top of the triangle. Okay, that is what the angle of elevation means, but we must make sure that we start here at the horizontal. So make sure that you focus on horizontal. Okay, that is our first point of call whenever we are doing an angle of elevation and depression question. Now if we go over here to an angle of depression, okay, depression means to sink down, so it would be the opposite of elevate, and in this particular case, again starting here at this horizontal going across, you'll notice here that we measure the angle down from the horizontal. I cannot stress that enough. We measure the angle down for angle of depression and angle up from the horizontal for the angle of elevation. Now, my biggest hint that I can give you guys before you get stuck into these sorts of things is to draw a picture of the problem. Okay, that is going to be my number one hint for anything trigonometry really, so that you can make sure that you work with these efficiently. Okay, so why don't we actually get stuck into this? The first problem that I'm going to give you is this. It's a worded problem. So the angle of depression from the top of a 25 metre tall viewing tower to a crocodile is 62 degrees. Find the direct distance from the top of the tower correct to the nearest centimetre going to the crocodile. Okay, so essentially I've gone ahead and I've drawn a bit of a diagram here for us. Okay, here is the top of my tower, so from the ground to the top we end up with 25 metres. Okay, and now the other piece of information, that's just gathering that from that bit of information there, is that the angle of depression, okay, you'll notice here, if I just bring this down a bit for you to read, the angle of depression from the top of the tower to the crocodile is 62 degrees. Now what we need to do is we need to fill in this information on the diagram. Remember, we're always measuring from the horizontal. So in this particular case, the angle of depression going down to the top of this triangle is measured from the horizontal. That is what we're talking about when we measure the angle of depression. Now, you'll notice with trig, we always have to have an angle in the triangle, correct? Okay, so what we need to do is put this angle inside of this triangle. Find a way that we can use this information to put an angle inside of the triangle. Well, this here is a right angle. We can see that, right? We are allowed to assume that this tower is straight up, straight vertical, and this ground is perfectly flat. Okay, so because these two particular angles here are going to be complementary, they both add to 90 degrees. 90 minus 62 degrees is going to leave us with 28 degrees here. This is the angle that we will be using, the angle inside of the triangle, to solve this problem. Now, the final thing that we need to do is that we need to find the direct distance from the top of the tower to the crocodile. In this particular case, the direct distance would mean the hypotenuse, not the vertical up and down distance or the horizontal left and right, the direct, straight from the top all the way to the crocodile. So, I'm going to label that with X. So I know, and I'm being clear about what I want to go and find when I'm doing this problem. Now, just like what we would do before when we were working with SOHCAHTOA, okay, I do apologise for the messy writing on that one, okay, we need to pick out our ratio. In this particular case, we're working here with 28 degrees. The 25 metres, okay, is going to be adjacent, okay, adjacent to this side of the triangle, so we label that A. Alright, and we can also assume, by the way, I forgot to put this in here, that this is going to be right angled. Alright, so we know that we're working with a right angle triangle. It was safe to assume that. And also, so we've just established adjacent over here. The other one that we're going to be working with is the hypotenuse. And the reason why we know that this is the hypotenuse is because it's opposite the right angle. Okay? Now the only one that uses these two particular sides is cos. so we know cos of theta is equal to adjacent over hypotenuse. Okay, now we're just going to substitute in all of our information. So cos of theta in this particular case is 28 degrees. Be very careful not to put the 62 degrees in. That's an easy mistake to make. Right, which is equal to our adjacent, which is 25 meters, over our hypotenuse, which is x. Now before, when we were finding sides, we know that we can just swap these two. Okay? Right, because the variable is in the denominator here. So we can swap, I'll just move this up so we can keep this being seen, to end up with x is equal to 25 over cos 28 degrees. Now, putting this in on our calculator, again, the last piece of information that we need to work out on this question is that it is going to the nearest centimetre, okay, which in this particular case we're working with metres, so the nearest centimetre means 2 decimal places. So once you put this in on your calculator, this particular value here, you end up with 28.31 metres to 2 dp. Okay, I hope that helps.